Hello and welcome to Python for Engineers. Today I'm going to discuss a little about myself, review the course goals, review the prerequisites of the course, and then discuss why Python is a good programming language for engineers. A little about me. My name is Mohammed Athar. I have a BS in mathematics and an MS in mechanical engineering. My focus and passion is really in thermofluid. I've been programming for about 20 years, and I've been using Python exclusively for about 5 years. I'd say in my day-to-day work, I'm about 95% Python. The goals of this course are obviously to learn Python. We're going to introduce some numerical packages, work on creating informative visuals, as well as some user interaction, stuff like reading and writing from files, displaying data on the screen, allowing users to interact with that data. We'll obviously discuss logic and control flow, as well as functional and object-oriented programming. The prerequisites for this course are pretty low. An advanced first year or standard second year engineering student should be able to understand all of the math and examples covered in this course. If you've got a semester of physics under your belt, calculus through integral calculus, if you're comfortable with matrix math, nothing too fancy, adding, multiplying, we might calculate an eigenvector here and there, but I'll review how to do that if it comes up. I will be presenting examples that cover statics, dynamics, fluid mechanics, and machine design, but I will review those concepts before working on the code portion of them. One of the great things about Python is that it is free and open source. This is the license agreement for Python 3.7, and you should go ahead and read that whenever you get a chance. But the best part about this is that it allows you, let's see, right here, a non-exclusive license to it's royalty-free, worldwide, and you can reproduce, analyze, test, perform, display publicly, prepare derivative works, distribute, and otherwise use Python alone in any derivative version. You do have to include the license agreement in whatever you make, but it's a very versatile license. Another great thing about Python is its large user base. If, for example, we go to Stack Overflow, we see that Python has about 1.2 million questions. MATLAB, on the other hand, has about 83,000 questions. R has close to 300,000, and C++ has about 600,000. Java does have more questions. It was about 1.5 million questions, but Python is just heads and shoulders above MATLAB, R, and C++ as far as the user base goes. One reason I really like Python is that it has taken care of and abstracted away a lot of the boring stuff. This edition of XKCD, a webcomic I like to follow, really encapsulates that nicely. What they're saying is basically programming is fun again. You don't have to worry about the tedious things like importing standard packages. You can just start writing code. One thing that's really great about Python is that object-oriented is optional. Here's a coding example in Java, which for those of you who have studied it know that everything has to be a class. Everything has to be an object. And you have to explicitly state that. For example, for a simple Hello World program, we have to create a Hello World class, and then we have to create a main method in that class. Lastly, we have to call the system to just print a simple string. It's not too much better in C. You have to include a standard library just for printing. You have to tell it to use the standard namespace also. You don't have to create any classes, but you do have to create a main method. Lastly, I always thought this output technique was a little awkward. It's just very clunky and not intuitive. Also, you have to return stuff. Every function in C++ needs a return explicitly stated. And of course, the semicolon, right? I've spent more time than I want to admit debugging code simply because I dropped a semicolon. This is the hello world in Python. You literally just type print hello world. And in older versions of Python, you didn't even need the parentheses, right? Like you could just make a simple hello world program by asking it to print. It'll already take care of all the imports that you need. You don't have to create any main functions or any main classes. And it's just clean and elegant. and lightweight. Alternatively, Python is object-oriented optional. You could create a Hello World class in Python and assign it a main function, and it would just say print. But that's also simple too. Let's see, it'd be something like class hello, 1, 2, 3, 4, 5, and then def main, don't need self, 1, 2, 3, 4, print hello world. Obviously, this is just a clunky example to show you what it would look like, but it's nice because it also illustrates that Python is incredibly versatile. I want to conclude this first lesson by reviewing the Zen of Python. Once you have Python installed, you can just type in import this, and you'll get this nice little Easter egg to help you understand the philosophy of Python. I'm just going to read through it, and hopefully it'll help you better appreciate what Python is all about. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules. Practicality beats purity. Errors should never pass silently, unless explicitly silenced. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably only one, obvious way to do it, although that way may not be obvious at first unless you're Dutch. Now is better than never, although never is often better than right now. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. Namespaces are a honking great idea. Let's do more of those. So there's that. That's the end of lesson 1. We've reviewed the Zen of Python. We've discussed why Python is good for engineers. We've seen a few examples of what it can do, and hopefully we've gotten you excited about Python. The next lesson, we're going to work to install Anaconda, and we'll move forward from there.